sequence and series, no, limits. Okay, so what's a sequence? Well, sequence is like sequence of numbers. Say 1, 3, 5, 7, 9. What's next? 11. Okay. All right. And then you can think of sequences as a function on integers. So you can think of, like, you can assign numbers, like this is the first number, second number, third number, fourth number. Okay, so that's the way you can assign variables with sub-indices. Now, if a sequence moves by adding a constant number to the next one, to get the next one you add constant numbers. That's called arithmetic sequence. And then sometimes you can have something like 1 and 1/2, 1/4, 1/8. What's next?
1/16.
1/16. How are we moving to the next one?
Divide by half.
Yeah, or multiplying by 1/2. Same thing, right? So you can multiply by 1/2 to get to the next thing. And if something like that happens, this is called geometric sequence. Another one would be like, say, 4/5 and 4/9, and then 4/13, and then 4/17. What's the next one? 4 over?
4 over
21.
Yeah.
So I'm moving by 4 in the denominator, right? So this has the property that the reciprocal is an arithmetic sequence. Okay, so the reciprocal is an arithmetic sequence. Flip, 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 and then you see that so 5/4 and 9/4 are actually just one difference. So if you take the reciprocals, you see that it's an arithmetic sequence with +1 as the common difference. Okay, so if such a thing happens, such a sequence is called harmonic sequence. And then there are zillions of them. Okay, you can have all kinds of different kinds of sequence that some of them might not have names for. So here's an example of a sequence where it doesn't fit into any of these patterns. So 2, 3, 5, 7, 11. What's the next one? Okay, what's the next one?
15.
Not 15.
17.
Is it Fibonacci?
No, it's not.
2 plus 1
15.
plus 2 plus 2.
17.
17. Why 17?
4.
Because it wasn't 15, and we're going by odd numbers.
No, it's 2 is even.
So the interval.
Prime numbers,
two
it's
is-
Prime
numbers.
numbers, yes. These are prime numbers. Right?
Oh yeah.
They're all prime numbers.
So 19.
90 will be the next one, yes. So you can have sequences like that. And some of these sequences, when they appear, they might give you some important clues of what's happening. So that's why there's an internet website called Dictionary of Sequences, where you can search up sequences by putting some numbers in the beginning. And it will search up all the possible sequences with names or formulas that would generate them. And it will also tell you what's like the possible number that would be after this one. And of course, like if you just put the first 3, there are many different sequences that would have the same first 3 numbers, so it would have more choices. And people use them for research because if you see a specific sequence that might put a relationship with a totally different field, and you might be able to see some mathematical patterns and such. So knowing what kind of sequence it is actually quite important. Okay? In this class, I'll only ask you guys to identify these types of sequences, one of these three. The other ones we will put some formulas there, but I wouldn't ask you to name them. But at least for these three, you should be able to name them. Okay. So what about sequences? Well, we're also interested in the ways that you can define sequences. And mainly there are two kinds when it comes to infinite sequences. So one would be like explicit functions. So let's say you have an given as n over n squared plus 1. Now if that's given, what are the sequences here? So a1 would be 1 over
2.
And then a2 would be, if you plug in 2, you get 2 over
5.
And then you plug in 3 over 10. And so on. Okay, so if you give a formula, you can create the sequence. So that's like one way to define a sequence. Now another type of definition of a sequence is when you have a recursive relation. And here's an example. You might have like a0. Oh, by the way, you can start from a0 too. You don't always have to start from a1. Or sometimes you can start from a3, a4, it doesn't matter. Okay? All you are required to do is like, it has to be integers. Right? The indices must be integers. Okay? So a0, let's say, is 1/2. And then an plus 1, let's say, is like 2an minus 1/3. So let's think about that one. Do I want 1? Yeah, minus 1/3. So an initial condition with a recursive relation, and we're going to say that this is true for n greater or equal to 0, will define you all the terms of an. So a0 is 1/2, that we know. Well, what's a1? Can you try that? What's a1? You plug in 0 here. What does it say? a1 is twice of a0 minus 1/3. What's a0?
1/2.
1/2 times 2 is 1. 1 minus 1/3 is 2/3. So that's how you get the next number. Okay. And then you can plug in n equals to 1 in here, so that a2 will be twice of a1 minus 1/3. Twice of 2/3 is 4/3. 4/3 minus 1/3 would be just 1, right? Just going to give you 1, and so on, so on. Okay? So you can have a recursive relation like this one, and in differential equations, when you solve some really hard differential equations, you might end up getting such recursive relation. There are ways to get general formulas from a recursive relation, but I don't think we have time to cover that one. But these are the two main ways that you define a sequence.